Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Thank you, Anna. Hello, everyone, and welcome to this AI for Good webinar. My name is Gillian Makamara from the ITU, and I have the pleasure today to introduce this session, which will be discussing project resilience and the next steps for its minimum viable product. In October last year, the Global Initiative on AI and Data Commons launched Project Resilience with the goal of building a platform that would give people all over the world the means to collaborate and use AI to address challenges like what we saw in the pandemic and to contribute towards achieving the UN Sustainable Development Goals. We are here today with one objective, and we want to connect 3 groups of people to Project Resilience. Perhaps you were there at the beginning, but you haven't managed to keep track of the work, but you're still interested to know what has been going on 1 year down the line. Or you've been here throughout the whole journey and you want to share with us what you have achieved so far. Or maybe this is your first time and your first experience with Project Resilience and you're interested in contributing. Whatever the case may be, the goal today is for you to leave this session inspired to come on board and contribute to this work. We have a very long list of speakers today who are all very active contributors of Project Resilience, and they'll take us through this presentation, starting with the goals of the project plan, go through an overview of the platform itself, and explain to you what has been done so far for data exploration and what is intended to be done for the architecture, as well as the next steps. We'll keep hip-hopping or ping-ponging around through the speakers, so please bear with us as you see the changing faces. Babak, are you ready? Our first ping-pong.
Yes, thank you very much, Gillian. Project Resilience has the stated goals of creating a platform that enables collaboration on building predictive and prescriptive models. This means that it's a platform that allows us not just to create insights, but also help decision makers on the ground make decisions that impact their regions and their nations. And so it is a wide audience that we're trying to reach, and we are trying to establish data and guidelines to support sustainable models, because that is the biggest goal globally of the project. And to be able to serve multiple stakeholders and a variety of users globally. If we go to the next slide, as Gillian mentioned, the MVP work group working on a minimum viable product started in spring of 2022. We have more than 20 volunteers signed up, and we've started tracking the project. There is a Slack channel, there's a GitHub, and we've made some good progress, and hopefully the presenters today will be able to walk us through some of the work that has been achieved, and we hope that this can also be an inspiration for those of you listening that want to join in and help us build this system. This is truly an end-to-end system in many different ways. The MVP is supposed to be end-to-end, but also the project itself takes us from the data that's being collected globally to decisions that can be made globally. And of course, those decisions generate more data that can, kind of nurture this loop. So that end-to-end nature of the project is very important to us. If we go to the next slide, a very high-level outline of the project plan which, we, as I said, started in spring. We hope to be able to launch the MVP by mid-2023, at least at a beta level, and a full release by the end of 2023, and future expansions by 2024. We will walk you through some of what we've done. Obviously, a big part of this was recruiting volunteers. This is an ongoing task, and we continue recruiting, and towards the end we will have a sort of a call for more volunteers in various different areas where we really do need help. One of the very important parts of the MVP is to actually select the use case. We kind of knew that the use case will be in sustainability, climate area generally, but we weren't sure whether we can actually find the data sets and define the use case. So we've made some very good progress there. As you know, the fuel of these AI projects is the data. So just finding the data sources, typically disparate, sometimes not aligned temporally or regionally with one another, poses its own challenges that we work on. And of course, we, at the same time, this project is not just about defining or creating a data set, it's about creating software and a portal for people to gather. So some very important architectural work has gone into, at least initially, into the design of the system. And there is an important ensembling piece that I will talk to in a moment. So if we go to slide 7, we can show you more or less where we are with the project right now. As you can see, we are pretty happy with the project plan and delivery phases. We have defined a use case, I'm happy to report, within the general area of sustainability and climate, which obviously has a very, very global nature to it and local implications. So it kind of fits the project resilience profile of projects that we would like to tackle. And it's a very good first project. We are in the midst of data source exploration and analysis. We've done some sourcing of the data, some merging of the data and prepping of the data so far, and more needs to happen. And we do have a first high-level architecture. We'll walk you through it. More work obviously needs to be done in building it together. And there's work outstanding on being able to ensemble the models that are contributed globally from these users, these teams that come together in order to create models that are more powerful. In today's presentation, if we go to the next slide, a number of the volunteers will help present the work. Jacob is here. He's going to talk about some of the data work that we've been doing. Olivier is going to talk about the use case itself and go into some detail on that. And Prem is going to talk about the architecture and the design for it. So if we go to the next slide, let me just very briefly talk about the inspiration for the work and where we are. Yeah, so we started off with an X Prize back when the pandemic started, and that was the germinus, the actual initial inspiration for the project. The X Prize was set up for teams that were already working around the world trying to tackle the pandemic and create models like AI, machine learning based or simulation based models, not just to understand how the pandemic is going to impact their particular region, but also to understand what they need to do, what mitigation steps they need to take. What we realized was there are many teams working disparately locally, and it just begged the existence of a portal where we could actually bring these models together, share at least what these teams are seeing and doing. But then it was a natural next step to think about the fact that we could actually make use of the data that is being collected locally, as well as the insights and the models that are being created. If we go to the next slide, let me just illustrate this. If we have a number of models. Each dot here is a model that is giving us recommendations for what to do in our region to mitigate COVID. And these models have two outcome objectives, not one. Obvious one is reduce the number of cases, but another one is the stringency and essentially the economic impact of these models regionally. So if we actually look at these models separately and disparately, the blue points kind of give us a sense of how well we can do. Obviously, where we want to go is where the arrow is pointing. We want to reduce the number of cases as well as reducing the stringency at the same time. Now, what we realize is when we ensemble these models together, when we put them together and build on top of what these regions are contributing, we can actually build models, new models that do better than the sum of the parts. And those are the orange dots that you can see here. And this gave us this notion that it's not just getting the teams together to kind of collaborate and talk and discuss and, share, battle wounds, but their work itself, not just the data, but also the models that they're creating, can be accretive towards a more global solution that can actually benefit others. People that might not have enough access to data or models locally can actually benefit from models that are contributed. So that got us all excited, and that's how we actually set up Project Resilience. If we go to the next slide, the definition for the project is a place to go to define the scope, collaborate, and cohere multiple local AI efforts, tackling a global problem. So it's no longer a competition. We started with the XPRIZE competition. It's no longer a competition. This is really accretive. And we want to harness the global energy of these disparate local AI efforts. An important aspect of this system will be, how do we harmonize between not just the data, but also the models that are being created, so that we can actually fit them together and build these larger, more powerful models out of that. So a lot of the work in Project Resilience is around guidelines, standards, API that will allow for this to happen. If we go to the next slide, let me just give you a high-level overview of how a system like this works. So if we start from the bottom here, the real world, the globe, as things change, as a pandemic happens, or climate change is happening and we're affecting it, we collect data. There's a lot of data that is being collected regionally around this and aggregated. If we have people regionally and globally that are collecting this data be able to kind of contribute to a data set that we can then distribute for people to use and build models, that's one point of contribution. The second point of contribution is creating predictor models. What is a predictor? A predictor obviously is telling us what's going to happen in the future, but not in isolation. It will have to know what we are going to do to try to mitigate. And in the presence of those actions, it needs to tell us what's going to happen. So it can't just guess at what we are going to do. It will have to take that into consideration. So it's a model, simply put, that takes the context, elements we can't change, as well as the actions, elements that we can change locally. And it tells us what the outcome is going to be going forward. In the case of the pandemic, the two outcomes were, reducing the number of cases and reducing the stringency or economic impact. In the case of climate, we're going to talk about it. Obviously, we want to reduce emissions, but we also want to maximize energy production. We want to minimize cost. So we do have multiple outcomes that we want to solve for. And so if we have this predictor model, we can then train a prescriptor model against it that takes a context and tells us what to do. It says, oh, you're here, and here's your situation regionally. What do I recommend for you to do in order to get the best of all the outcomes that you're seeking? And as this is then rolled out and the actions are being performed out in the real world, The decision maker obviously has a very, very big role. They can decide what to do, which actions to pick, which not to pick. And if they actually choose a different set of actions, they can run it through the predictor and see what the implications are going to be. But as this is rolled out, new data is being collected, and this whole loop is completed. So we can now collect more data and come in. So Project Resilience is on the foundation of collective data collection, collective creation of predictors, and collective creation of prescriptors, and the rollout of this system for use globally. If we go to the next slide, obviously what I mentioned up till now is very ambitious. For an MVP, we have to bring it down to something that we can actually build within reasonable time and with volunteers. And so what we've done is we reduce the requirements to the data already existing and being publicly available and not having security privacy constraints. And to reduce the load on our side for the models, we decided, okay, we will let the regional teams that are contributing the models to actually host the models as well. And we can call the models as they're being hosted by the regional teams. But with the caveat that we would like to know the entire process of creating the model. In other words, we would like to know what data went into creating that particular model and how it's set up. So these are requirements that might be relaxed as we go forward in future phases, but for the MVP, these are the requirements that we've set. Let's go to the next slide. At this point, I would like to hand it off to my colleague, Olivier, to talk about the use case that we've selected as part of the MVP project. Olivier?
Yes, thank you, Babak. So the use case we selected is about mitigating climate change. And there are a lot we can do in this domain. What we looked at more precisely is transitioning to cleaner energy sources. And the goal is to reduce the emissions, obviously, but at the same time mitigating the cost on the economy and still producing enough energy. It would be easy to minimize emissions if we were stopping producing energy completely, but that's not a possibility. Next slide, please. So we looked at a lot of data sources, and there is a lot of data available about climate change. So what we are looking for in particular is historical data about decisions that have been made in the past. And we want to look at the context, what situations the decision makers were in, the actions, what they did in this situation. And we want to look at the outcomes. How did these actions turn out? Was it good or was it bad? And we want to learn models from these previous decisions and see if we can improve them and at least see what works and what did not work. Next slide. So what kind of data do we need more precisely? So we want to cover enough variations of decisions. So we need to make sure that we actually capture good and bad decisions. And we also need to make sure we cover many different situations. In our case, many different localities. We want to be able to observe the results of the actions in a reasonable amount of time. So plans for the next 25 years are not something we can actually work with. We need to be able to observe what the outcome is in a reasonable amount of time, like 3 months or maybe up to 1 year. The data should include past decisions and their consequences. So the context, action, outcomes have to be one decision and one observation. And finally, we want to make sure that we use reliable data. Like for any data science project, the data is key. So we need to rely on good quality data, on good sources. So to refine on what we mean by context, action, and outcomes. Context is what the decision makers can't change. It's fixed. There's nothing they can do about it. Like the region they are in, the population size, the GDP, all these kind of things, there's not much they can do about it. It's a given. But on the action side, there are things they can do in order to mitigate climate change and reduce the emission of their locality. At a regional level, they can propose transition from coal plants to cleaner energy sources, for instance. They can provide subsidies, and they can vote policies, put in place policies. And ideally, we would like to observe the direct results of these decisions in the emissions at the local level, at the regional level. And at the same time, we want to look at the cost that it had and the effect it had on the energy production. As I was saying earlier, it would be very easy to cut emissions completely by stopping producing any energy, but that's not viable. So we want to mitigate the emissions with the level of energy production and the cost to transition to these better sources of energy production. So now Jacob is going to talk a little more about data sources we looked at.
Hi. Yeah, so this is one of the data sources we've looked at. So we are trying to pull data from, like Olivier said, as many different places as possible that are trustworthy. So places like the World Bank or the IEA or OECD. This example is from the Global Energy Monitor, Global Coal Plant Tracker, which works to track all proposed under development, operational, and retired coal plants worldwide. So this is close to like an ideal data set for us. It has worldwide coverage. It goes back not quite 10 years, but it started in 2014. It has fantastic regional resolution. It has both like the country, the like state or province these power plants are on, down to their own like latitude and longitude points. And it's not quite at the temporal resolution we want. It's updated every 6 months. And so we do get changes, but we have to like interpolate to get down to quarterly data points. But this is one example. We've also looked at subsidy data and how subsidies change over time for more different types of actions for kind of this. We've done things for like land cover usage. So there's been some recent work on globally quite often updated land cover maps, as well as different ways of the cost of energy and the cost of building renewables and like renewables and batteries to replace coal plants or gas plants. So give back to Olivier to go on one example of working with our data.
Yeah, so one example of what the kind of project you want to put in place, what kind of decision system we want to put in place. So we need to train models on this data, and we need to provide the decision makers with a tool to choose which objective they want to favor. In this example, we have the cost on the bottom axis and the emissions on the y-axis. And these two objectives are orthogonal. So the decision makers, if they are in a rich country, they can probably finance subsidies and tariffs to lower emissions. So they would pick a model that make recommendations with higher cost. Countries with less financial means would probably choose another point on the Pareto plot. And then we want to train a predictor model and a prescriptor model, like Babak said. We want to be able to compare them, to ensemble them. And then we can provide a user interface to the decision makers where the decision makers enter their situations. In this example, that's the effectiveness of their local governments. And the system can make recommendations about what the decision makers could do. In that example, it's about setting feed-in tariffs for energy, for wind and solar energy. And given these actions, we can actually call the predictor model to get a prediction of what's going to happen. And if the decision maker doesn't like this prediction, the decision maker can try, what if I increase my subsidies on wind energy by that much? And then ask for another prediction and see how things are going to turn out. And I'll hand it over now to Prem to talk about how we can gather the data, train these models, compare them, and deliver them to decision makers.
Thank you. I'm Prem. So, as the team was talking through, it's very important. There's a lot of work is being done globally. It's important to, have this environment for them to do this work. There's a lot of work on data, models being created. So the objective of this architecture is from a high level requirement wise, that we want to enable a platform where we're able to build models, bring the models, able to get the data, save the data, and have this best experience for the data engineers come in and contribute to this work. We have the AI community of contributors, consumers, regulators, different people maybe playing the role here. So they need this environment to come in and one place they can use this platform to collaborate. So that's the high level, and also is reusable, right? We saw, this work is done on COVID. Now with the climate change, we see, once this platform is laid out, we could use for other initiatives that we'll be working on too. Again, this is a lot of stuff is done by volunteers, and we're able to scale up and down. We are very, very conscious of the cost effectiveness of this platform too. So that is always back of our mind when we build this architecture. And also secure environment, able to, the right people getting the right access and able to do their work and getting the best experience. And the key components, for this requirements for this architecture is, able to come in and work on this safe environment. That's the AWS catalog. So we kind of looking at multiple cloud providers. In this example, we talked about AWS. So when the other users, multiple users are coming in, the AWS Service Catalog is a great tool which restricts the access based on who the users are, and they can able to access the appropriate services. And the studio, SageMaker Studio, offers an awesome experience for data engineers to come. Data scientists to come in and able to access all the data. They can bring their own data, or the data that's already existing. They can use the data and they're able to quickly build the model and experiment the model and train the model. And if it is the right model, then there's a project templates available in the SageMaker MLOps process, where they can create those templates and create those workflows where they can run through the process end to end. If you go to the next slide there. Yeah. So once that's this topic is pretty detailed, too technical. I want to stay at a high level, so I kind of go on high level. And then once the model is available, we want to separate that environment between the development environment, also in the production environment, where want to consistently run multiple models. The prescriptor model, the predictor model. We want to run that for multiple iterations. When the model is running, we want to make sure we are automated a governance process in place, model monitoring, and the data monitoring, the drift and model drift are monitored, and also any regulation rules need to be applied for those, or it's more automated, are in place as we evaluate those model and bring that information together. And obviously, we want to be in the secure environment. It is not available publicly. So only the restricted users are able to come and access this our infrastructure. If you go to the next slide, please. And data lake is we're going to deal with a ton of data, obviously, and there's a lot of work worked on data. So collecting the data, we want to make sure that data is secured and easily accessible. And right now, the game plan is really get the data and save that in S3 environment and is secured. And data will be available through the studios as well as through the model process. Once the inference is run, the model is the outputs are ready. We plan to use quick Amazon QuickSight, quickly look at the dashboard, especially the decision makers will be probably using a lot of them, looking at the training of the model, comparing the model, and pick the right model for the work. And also, we can quickly spin up the web app too around that data and provide that to the right users to evaluate, helping with the decision making, and look at the training of those models, how they're performing. And the last not least, bring your model. Across the globe, multiple teams are working on this model. They may have a different architecture or environment they may be working on, but also we want to give the ability for them to build their own model, bring into our architecture, and go through the same workflow where we can look at the insights of those models and compare against other models and make the right decisions. I'm going to turn over to
me. Yes, thank you, Prem. And so the next step to complete the MVP, as you saw, the team showed us where we are as far as picking the use case. We even saw some sneak peek screenshots of some of the work that has been done already on a use case on the data set as well. You saw what we think is a scalable architecture to scale beyond the MVP, at least the design for it. Now, a subset of that architecture is what we really need to move forward to actually get the MVP going. But there are some other work tasks that we need to do as part of the MVP. One is the ensembling of the models, which is an important part of what we're talking about here. We need to write a module that allows us to take contributions and ensemble them. Of course, we can't take any old contribution. There has to be an assessment of the contribution itself, how well it's working, whether it's complying with the regulations and standards that we've set, and how well it's working with respect to the other models. So that's a module that we need to build to be able to do this evaluation of the contributions. And of course, we have to complete a set of guidelines for these contributions. So as you can see, a lot of work is still outstanding. If we go to the next slide, ultimately, this system will go beyond just data scientists contributing models. There are going to be multiple personas interacting with this system. Let's start at the top, the AI consumer, the person or persons or regions or decision makers that define the problem in the first place. They have a very, very important part in this ecosystem that we're creating. Then there's the regulator, be it governmental regulator, United Nations based, but it could also be a regional based, but it could also be AI ethicists and folks that we bring in to help us, create this in a responsible manner. We obviously need support, not just volunteers, but also monetary support. And so people that want to come in and contribute, select a project and say, hey, this is important to me, I'm going to invest in it. They should be able to kind of come to this portal and help with the whole process. And of course, very importantly, are the AI contributors, starting from the data, which is of utmost importance, not just collecting it regionally, but also being able to harmonize it across regions, all the way to creating the different types of models that we discussed today. Okay, so at this point, let's go to the next slide real quick. More immediately, there are 2 work groups that we can actually launch even today to start working in parallel based on the work that we've done already on the MVP. One is on the data contributions side. There's a lot of work to be done. And if we could get a work group together that can actually focus on the data, the process for the data, the collection of the data, the merging of the data sets, and getting them to a standard that we can use, that is very, very important. Of course, the ethics of the data itself and its collection is also of importance. So we need a work group to start just parallel tracking with us and focusing on that. As you saw from the last slide, there's a number of different personas that will end up using this system. And so the user experience, that persona experience, becomes very, very important for us. And being able to kind of think about the needs, the requirements, the workflow for each one of these personas going through the system is important for us. And of course, helping us define and design what goes into creating the portal or the window into the portal for that particular user persona is important. And I think that's also a track that we can launch in parallel very soon, if we can get the people to volunteer and help us with that. So yes, at this point, I actually want to pass it on to Amir, who this whole project sort of is his brainchild. So I will pass it on to him to walk us through, the ask that we have from this community. Go ahead, Amir.
Thank you very much, Babak, and hello, everyone. I'm glad to be here again. As you saw and heard from Babak, Julien, Prem, and Jacob, and Olivia, of course, the project has been progressing quite well in the past 12 months in terms of the MVP. And as Babak included in his comment, now we have the opportunity to start 2 additional working groups that we had actually announced and initiated, but for lack of progress on the MVP side, with that they may not be starting soon enough. But right now we're already on those. I'm going to explain a little bit more. We talked about data contribution. We used, of course, COVID-related data and health policy data at the beginning. And now we're switching to climate-related and energy-related data set, but there is much more that we can do. So if you can move to the next slide. The project right now is in a phase, maybe in another slide too, the next one after that, if you don't mind. Yes, this one. So the project today needs a few elements that will be really push it forward in terms of really contributing a publicly available set of software and data for many organizations and countries and cities that will benefit from Project Resilience, because we're planning it to be a public service available to everyone. So for that, you can see in order on the green side, we're trying to complete the MVP dataset to include, as was mentioned, context action and outcome variables, but also think about how we can include private and public data set that may improve some of this effort and get us better focus or specifics in terms of applicability of the models. We need also to have more expertise and support to help build the models and enhance them. Right now, we're working with a limited team that has been carrying the load. That we think that with the progress that we have right now, publishing in GitHub and making all the elements available, more talent and skills can help join us in this effort. And the time and skill that were needed are, of course, building models, but to make sure that the outcome also is being made available to the non-data science community, because what was mentioned is that there is an AI consumer, the AI user, for which we're trying to build a persona. It has to be useful for everyone. We are working on how this insight can be made available to those who need to understand the value of that data and to work on mitigation models and improving. Right now, we're working with with a small group, but with the help of ITU, we're trying to connect this work with the focus and study groups that are working on standardizations, so that they can include some of this work in the existing frameworks and to evaluate further improvement or benefit in terms of standard work. We are also starting to fund this effort now that we have a foundation for a 24 months with a dedicated team of 2 or 3 people that could really carry this project to its completion, so that it becomes a publicly available, sustainable project for everyone to use. If you can go to the next slide. So the type of volunteers that could help at this very moment in terms of volunteer alone, as you can see on the screen, naturally, machine learning and AI related talent, data scientists, but definitely DevOps and system integration, because we need to put it together. And also from a project management, we need help from people that are in tech program management capacity. We hinted to the issue that we try to gather data and make that available. So there's always an impact on the legal side, on the ethical side, on privacy, security, access, that we are not overlooking. And we would like also volunteers and individuals that have insight, experience in those elements, so that when we publish a public good system, how this public good can actually remain public good and be made available to everyone. This is what we have right now. So we need to really work with organizations that either can contribute directly time and effort and resource, or help us with some light funding to get this project to completion, but also help us with data, help us with additional insight or contribution to bring it to fruition. Thank you very much for all these efforts so far, and we're very excited for the next phase. I'll pass it on to Gillian, and ready for next questions after that.
Thank you, Amir. I think we've come to the end of our presentation today. Feel free to put down your questions. We're still here for another about 15 minutes, so we'll be able to answer your questions. If anybody is already inspired to join this effort and to contribute, I would encourage you to look through the session description and visit the Project Resilience webpage and join the community on Slack. Once you're in there, please don't be shy. Introduce yourself, tell us a little bit about what excites you about this project and how you would like to help or contribute. We really look forward to welcoming you all on board. So please feel free to put down your questions in the neural network, and we'll be able to answer them. But in the meantime, if I could take you back to the architecture, because we kind of glossed over that. For now, I can see that there's a, I guess, outline for what can be expected to be built. Can any of you share what the timelines are to do this, and why do we have here AWS, for example? Prem or Olivier?
Yeah, I can take that. So yeah, this is going to be really MVP approach, right? And this is the end state to accommodate, to multiple different requirements, more sustainable product. But we're going to be really taking the MVP approach on this architecture. Once we scale out the work and build the minimum component that needed to get the work done. So AWS is definitely a strong candidate, but we are looking at other cloud providers too, if they can meet all the requirements that we're looking for short term and the long term. So we didn't finalize exactly which cloud provider we will be choosing, but we're looking through all the other options too.
Great, thanks. Thanks a lot, Prem. I'm not sure if anybody else has anything to add, but feel free to jump in if you would like to. Another question perhaps that we could ask, we have these assumptions and we have the list of data requirements. Could maybe one of you share the process that has gone into this data collection, where we are right now, and if somebody online wanted to jump in today, where exactly could they come in? Babak, Olivier, or even Jacob?
Yeah, we've been looking at publicly available data sources so far because it's easier than anything private. And the key is to actually have this, let's call it a CSV data set, where every row is a decision that has been made in the past. And the key is to be able to compare decisions that have been made in different situations, maybe in different countries. Like for COVID-19, we could compare what was done in China with what was done in France, what was done in the UK, or even in Sweden. And then we could compare the effect of the actions. In the case of COVID-19, Sweden decided to be not stringent at all, and we could see the impact and compare that with China, which was really, really stringent. So that's the kind of decisions that we're looking for: situations, actions, and how the actions turned out. And in the case of climate change, we have a lot of data about the outcomes and about the context, but we have a hard time finding the actions the decision makers are making. So the data around these decisions is not easily available. But like we said, there are a lot of decisions that are made in this domain. Like it could be transitioning coal plants to biomass or something else, because we can reuse the infrastructure of the plants. It could be about subsidies, it could be about tariffs, or any other local decision that that decision makers can do.
Yeah, just to add to what Olivier said, there's also the fact that oftentimes what we find is that the data is disparately collected. So you might have, for example, subsidies data on energy or energy transition decisions in a different data set, different form, on a different timeline that's collected. And there you might not actually have the emissions, or you might not actually have enough of the situation or the context of the region, or the regions might not overlap. One might be country level, one might be at a different level. That is still good, but it does take some data wrangling and work on the data to be able to put it together into what Olivier just mentioned, that one line in the data set that includes attributes that pertain to the context, the actions taken, and the outcomes that were achieved. Also, sometimes the outcomes are at a lag. I mean, often the outcomes are at a lag. So identifying that is important. In our case, Project Resilience, the data that is going to be generated regionally is also going to have to be harmonized. In the case of COVID-19, we were lucky that there was an army of volunteers with Oxford University that actually worked on harmonizing the action data from different regions. It might be that school closure at a certain stringency, or work closure, or public transport closure at a certain stringency is defined differently in one region versus another. And so it's very important for us to be able to harmonize those so that we're not talking about apples and oranges.
Yeah, one last point is that we want to iterate on this data set. So every time a new decision is made, we want to collect it so that we can train better models on it. And the faster the cycle, the better.
Right. Thank you. We have a question also about the data concerning the availability of outcomes. I know you've already talked about this, but perhaps you could give a bit more context about this. The question is concerning the availability of outcomes in the data. This seems near impossible to find in the time frame that you want compared to the actions. Emission reduction data will take years to manifest for regional subsidy decisions. So what do you have to say, Olivier, about that?
Yeah, it's indeed difficult to get these outcomes, but it's not impossible. Data sets like those provided by the OECD gives us a detail of the emissions per sector, for instance. So we can focus on the emissions that are produced by the energy sector, for instance. And that's what we want to correlate with the actions about energy decisions. So yes, this is one of the toughest problems we have to solve right now. It's linking the actions with the outcomes. And in the case of emissions, the outcomes are difficult to measure, and they are usually more global than what the actions are targeting. So we need to make sure that we are at the same level and that we can compare local pieces of data. Yeah, if you have any ideas on where we can get this kind of data and how we can map the actions with the outcomes, we take them.
I see Babak is smiling. Is that an agreement?
Oh yeah, for sure, absolutely. I think it's very, very important. This is a global problem. It's not a simple one. That's why we're all coming together. So yeah, absolutely. Sometimes we have to rely on emissions data that's a derivative of what's actually happening in that region versus an actual readout of the emissions in that region. And as Olivier said, total CO2 or climate change data is a global affair. You emit here, it doesn't really care what region you're in. It's going to impact everyone. But these are some of the challenges that we have to come together to address, and I think they're addressable.
Right. I have a question to, I guess, Jacob and Prem, who aren't really here with us when we launched Project Resilience. Could they maybe tell us what the benefits have been so far through this process and what actually is bringing them to keep contributing to Project Resilience? Jacob or Prem?
Yeah, I found it looking, just up different things, and it seemed like a cool way to try to help with climate change. I work for Open Climate Fix, so my main job is working on forecasting short-term energy stuff. So it's I thought I'd have quite a hopefully useful skills for this. But trying to do it on like a more global scale and being able to find some data. Some of the companies that we also work with have had some data that's been quite useful for this. It's cool seeing that it's moving forward, that we now have some basic models. We have data sets slowly coming together and actually making the MVP now. So I can
I can add my 2 cents here. So it's kind of new to me initially when I started this. Although I'm in the space of architecture and cloud for a long time, but obviously climate change is something I'm passionate about. I am. My thing is like this team is awesome to work with. We meet bi-weekly and this very collaborative, very passionate about what they do. Just fun to be something a lot of stuff going on in our life, and this is come and do something and everyone enjoy what they do and contribute to that work. I just enjoy that. So
That's great. I don't think we have any other questions coming in from the audience. I saw Amir wanted to say one last thing before we close. Amir?
Thank you, Gillian. Yes, I wanted to reemphasize that everything that has been done doesn't necessarily show here when we explain it. There is a lot of complexity and nuances. And really, when we think about how we can provide not only prediction, but also prescription capabilities to organizations that don't have the data scientists, that don't have the machine learning experts, don't have the capability to actually benefit from all these capabilities that machine learning AI can provide. So we're really welcoming other people to join us and to help us. as was mentioned by the discussion now, Join for 1C is fun. We're doing something really interesting on the ABV side, but also on the data contribution and persona. You can really shape this project by your contribution. And this is really thanks to ITU and thanks to the effort that have been done from XPRIZE and Cognizant all about 2.5 years now. This is the very first time that a concept of a publicly available AI system is shaping up. So you can contribute a lot to make this happen and make it real. We're going to be continuing, but we'll welcome every other people that could help, an organization that are curious to help us with that. So yeah, really excited about this progress that we're sharing with you today, and hopefully we are getting more help and moving it forward to a global public launch within the next 18 to 24 months. But already it's going to be available for testing and engaging with. It's not that we're hiding it, but when we mean public launch, I mean that at the phase where it can be publicly available to benefit end users, and as we called it, AI consumers.
Thank you.
Yeah.
Thank you, Amir. And thank you, everybody, for the questions and for joining us. Once again, before we go, I'd like to encourage you to take a look at the webpage. You can find all the information about the project and how you can contribute on there. Once you're there, please join our Slack channel where you can meet the rest of the team and start collaborating with them on this work. Again, don't be shy, introduce yourself and tell us what you would like to help with Project Resilience. You can rewatch this session in the Neural Network or on the AI for Good YouTube channel, and share it with all your friends and colleagues that you think could be interested or who you think could contribute to this. And for now, we'll be closing, but we hope to speak with you soon at our next meeting for Project Resilience, which will be on the 25th of November. Right. Thank you, everybody.